I scream, you scream, we all scream for ice cream. Now, hey, has anyone have you ever actually screamed for ice cream? I mean, ice cream is good, but I don't know if it's that good. But anyway, there's an ice cream cone on the screen, and we're going to talk about ice cream today. No, actually, we're going to talk about scatter plots and trend lines in our section today. We have two goals, and I'm going to change this goal slightly. We're going to cross this out. I'm going to say I can write an equation of a trend line, and we're going to call that a line of fit. Okay, we're not going to deal with lines of best fit. Those are slightly different. And then I can use trend lines to make predictions. So those are two goals for today. Let's start off with a little bit of vocabulary. Not what the definitions are. You'll have to look for those. These two with the stars for sure you got to have down. And these three are important as well for taking for especially looking at the picture of what those would be. And a line of best fit we may or may not get to. So those are the words we're going to work with: scatter plot, the three different types of correlation, a trend line, and a line of best fit. And a trend line is really, like I said just before, it's a line of fit. Alrighty. Not sure what's going on here. Alright, anyway, we're moving on. A scatter plot, here's the first term. A scatter plot is a graph, so I'll just underline what's important here. A graph that relates two different sets of data by displaying them as ordered pairs. So it's like you're graphing ordered pairs. So you don't have to write down the rest of this. But most scatter plots are in the first quadrant. That means the upper right quadrant of a coordinate plane. We're only using all positives. Um, and there's different trends that you see in data. That's why we're going to be talking about a trend line. And there's three different types of relationships in data. The first one is a positive correlation. So a positive correlation is as when the y value increases, the y value increases as the x value increases. So if you look at this one diagram, essentially it goes up from left to right. So it looks just like it would be a positive slope if you're comparing it to what we've been working with slope. Um, a negative correlation would be the opposite. It's as when y decreases as x increases. So as you go up in the x's, the y's are actually going down from left to right would be a negative slope. Looks like a negative slope. And then finally, the last one is no correlation. So it's when x and y really are not related at all. So I'm going to say there's no pattern. If you look at the graph above, there really is no pattern. You can't see any general pattern, any general line. They're just all over the place. So that's called no correlation. So now we know what the different types of correlation and what a scatter plot is. Let's work with that a little bit. So we're gonna do a couple things. We're gonna make scatter plots, and we're gonna look at the correlation of them, and then we're gonna talk about trend lines. So first of all, making a scatter plot and describing its correlation. It says the table below shows the altitude of an airplane and the temperature of outside the plane. So essentially, it's like what as the plane goes up, what's happening to the temperature. And it looks like if you look at it, it kind of went up a little bit right away, but then it's generally going down. Um, so the higher you get up in a plane, typically it gets colder. So let's actually do something with this. Let's make a scatter plot first. So treat the data as ordered pairs, just like if we had a t-chart going left to right. Um, Graphing these points, you'd have the altitude would be the x and the temperature would be the y. So the first one we'd plot would be 0 and 59. So if we look actually at our scatter plot that's already done for us over to the right here, looks like this would be 0. Um, so 500, I think it's going up by 500s. 500, this would be 1000, and so forth. And it says if you were to graph them, like you know how to graph ordered pairs, the x and then the y, it looks like it does have a definite correlation here. So if you look at this, uh, actually, you know what? I didn't uncover it far enough. It is labeled there. So it is going up by 500s, and they're only showing the every 1,000 here, though. So if you were to graph it right here, um, it does tend to go down from left to right, meaning it looked like it would be a negative slope if this were the line. which means it has a negative correlation between the altitude and the temperature. So let's try one on your own. I seriously want you to do this one on your own. Take a piece of graph paper or make your own. It says make a scatter plot for the data in the table below. What type of relationship does the data have? So we have gasoline purchases. The dollars spent, how much you spend. How does that affect the gallons of which you bought? Whoops. So first make a scatter plot of that and decide what the correlation is, if there is any. And then we'll talk about a question together. So what I did here for you was graphed that. And I set it up like this graph right here. And I made my scatter plot. Um, the x's, again, were the dollars spent, and the y's were the gallons bought. So I plot the points, and you can tell right now there's definitely a correlation. It almost looks like an exact line going up from left to right, something like this. So the correlation there is positive. It's definitely a positive correlation. Positive correlation goes up from left to right. There's a positive correlation between the dollar spent and the gallons bought. Now, the question here is, it says, consider the population of a city and the number of letters in the name of the city. Would you expect a positive correlation, a negative correlation, or no correlation between two sets of data? Explain your reasoning. So the two things we're talking about here are population and the number of letters in the name of the city. So like if we were to make this graph here, we're saying as the population goes up, does the number of letters in the name go up? My guess is no. I don't think that has any correlation. You could be in Chicago where there's like 9 million people in it, and you could be in Milwaukee where there's only 500,000. And Milwaukee's a longer name. But you could also be in Los Angeles and there's tons of people, and that's about the same as Milwaukee, or New York. That's smaller even so, and that's probably even bigger of a city. There's probably no correlation between those two, um, if you were to think about it. There's no correlation between those two. So now let's take this and talk about what trend lines are. So trend lines are, this is our last term, a couple of terms here, but trend lines are the most important one. A trend line is a line on a scatter plot drawn near the points that shows the correlation. So what I've been doing is drawing trend lines. Like this right here, if I go back, sorry. If I go back to what I just had here, this red line is my trend line. It kind of shows the correlation there. If I go back to here, these blue lines are my trend lines. They show the correlation there. They're very close between the points, and they show the correlation. Um, and we're going to actually use those for different things. There's two trend lines here, these blue ones. It says you can use a trend line to estimate a value between two known data values or to predict a value outside of the range. So, two terms here. Interpolation, if you are asked to interpolate, it's a nice big word, it's estimating a value between two known values. So, like, if I would say, what is the y value in x is right here? We'd estimate it based on that line, it'd be right on there. Okay, it's just an estimate. Extrapolation is predicting a value outside of the range of values. So extrapolation would be like, what if x was way over here? Y would probably be up there. It's taking that and you're taking something outside of it. So think of exiting, you're going outside. Extrapolation would be looking for something outside of what you're given. Interpolation, so inside, would be estimating something inside of that data set right there. So let's use that. Let's use some trend lines and find the equation of these trend lines, so that we could perhaps we could write the equation of what we think the basic trend is. So it says make a scatter plot of the data at the right. What is the approximate weight of a 7-month-old panda? So we're going to have to make the graph first and then do our estimating. So it says make a scatter plot and draw a trend line. Estimate the true coordinates of the 2 points on the line, or of 2 points on the line. So what we're going to do right here is we are going to graph these. So let's set this up. I think these are all going to go up by ones. This would be x and this would be y. This would be our x, just like it always is. Whoops. I say whoops a lot when that happens, don't I? That's the y. So the x would be the age. So we're going to go up, let's see, 1, 2, 3, it goes up to 12. So we're going to do by ones. So it'd be 0, 2, 3, 4, 5, 6, 7, 8, 9, 10. Goes up to 12. The weight, it goes from 2.5 to 50. Let's go up by fives, I think. So we're gonna go 5, 10, 15. So we're gonna do this would be 10, 20, 30, 40, 50, and it goes up to 60 then. Alright, so that would be the weight, the pounds, and this would be the age. And we are gonna graph those. So I'm gonna pause here. Why don't you graph those on your own? Alright, so there's my points. I'm going to draw a trend line. So I'm going to say it's going to be right about there, right through those. And it says estimate the coordinates of 2 points on the trend line. So let's say we have, oh man, this is not the best. Well, I'm going to find, let's do, this one will be 11 and 52.5. Well, we'll say 52. Again, these are estimating. And this one would be 6 and 28. Okay, that's just an estimate here. All right, what we're gonna actually use those to do something with this. But let's also estimate. It says estimate what's the weight of a 7-pound old panda. We could check this and just estimate. 7-pound old panda would be 7 pounds would be right here. It should be right about here. So I'm gonna say it's gonna be about 32 pounds. That's my estimate. What we're going to do is we're going to actually write an equation of the trend line. So I want you to be able to do that. Um, when you're given 2 ordered pairs, you can definitely write the equation of a trend line. Just treat it like 2 ordered pairs. So we have 1152 and we have 628. I'm going to first find the slope like we always have to do. So I'm going to do y2 minus y1. I'm going to actually flip these around and let's go like this. Well, we'll leave it. Leave it like this. So we'll do 28 minus 52 over x2 minus x1, which would be 6 minus 11. We have negative 5 on the bottom, and it looks like we have negative 34. Oh, sorry, 24 on the bottom, right on the top. Okay, and that reduces to, well, that doesn't really reduce at all, does it? But it'd be 24 over 5, which would be, well, we'll leave it like that. If you want to change it to a decimal, you can. But we're going to then take that and yeah, you know what, I'll make this one into a decimal. It ended up being 4.8. So let's use our slope-intercept form, y equals mx plus b. Plug in 4.8 for the m. So we have 4.8 is right here. We'll use the x, we'll use the smaller ones, we'll use 6. And then the y would have to be 28. That's our ordered pair that we chose. Plus b. 6 times 4.8. 28.8. And then when you solve for it, you subtract 28.8 from both sides. And you're actually getting b is equal to negative 0.8. So if we wanted to make that into an equation, we'd have y equals 4.8x plus negative 0.8. That's our equation of this line. Now if we want to figure out what it is when a panda is, was it a panda? Is that what we're talking about? I forget. Yeah, 7-month-old panda. So the age is the x, so we can plug in 7 for x. That's what it is. Estimate the weight, so we can do y equals 4.8 times 7 plus negative 0.8. Check on our calculator what 4.8 times 7 minus zero point 0.8. It's going to be about 33.1 pounds. And we estimated it was about 32. So that's pretty darn close. All right. So what I'd seriously like you to do, and I'm going to check you next time, is to answer this one. Make a scatter plot, draw a trend line, make a scatter plot of the data, draw a trend line, and write its equation. Okay, and then you can check the body length. This is body length of a panda based on their age. All right, that's what I'm going to see from your notes next time. Otherwise, that's our lesson on scatter plots and trend lines and finding those lines of fit or trend lines. All right, we'll see you next time.